research group aiming to bridge the gap between postgraduate doctors in training and research. And we do this by advertising available opportunities and providing some opportunities to develop research skills. And we also hope to work as a platform for multi-center regional audits, QIPs, and research. So just to introduce Neil a little bit. So Neil is a pediatric registrar who is currently out of training. He's an NIHR doctoral research fellow. And today he's going to be talking to us about collaborative opportunities for funding free research. And thank you very much, Neil, for doing this for us today.
So I'm just going to share my screen. Can you guys see that okay?
Yes, we can see that. Great, thanks.
Yeah, thanks for the introduction. Yes, my name's Neil. I'm ST4, currently out of programme in South Yorkshire, working in Sheffield, doing a PhD in applied data science. And I'm just here to talk about some different ideas and ways that you can get into research without the need for massive amounts of funding. Because essentially we're in a bit of a chicken and egg situation, aren't we? In the sense that if you don't have any money for funding and you're trying to get some, you won't be successful if you've not done any research. But if you haven't got any funding, how do you do research? And I think the answer is that you do have to do some research first before you can get any decent money for research. And therefore, you need to be looking out for these opportunities that mix themselves well with your interests to be able to get some good quantitative research output in order that in the future you can really get people to give you money to do stuff that you're really interested. And so I'm going to describe to you a research idea and project and just frame around that some ways that you can turn research ideas into research outputs before needing to get enormous amounts of money. And this idea is around the newborn infant physical examination. We have 700,000 babies born every day in the UK, and people like me or midwives or advanced nurse practitioners carry out the newborn infant physical examination. If they hear a murmur, then they'll refer the baby for an echocardiogram. Unfortunately, we know that this process has a relatively low sensitivity and a relatively low specificity. So we're missing a lot of cases of congenital heart disease that do end up needing treatment and present in extremis, unwell or for other reasons later on down the line. But we're also doing an enormous amount of normal echocardiograms on babies. And this is costing the NHS a lot of money because an echocardiogram on a baby is a highly skilled procedure and it needs skilled staff to do it. So instead, if we were able to digitally record the heart sounds with a digital stethoscope, many of which are on the market, and use artificial intelligence to analyze those recordings of heart sounds, we could well improve the accuracy of the screening of congenital heart disease and in turn save the NHS a lot of money. Now, let's take that example of research that currently I've got a funding proposal in and waiting to hear about in the grand scheme of things, and just figure out different aspects of that anyone could take and own to be their own in order to contribute to that wider project. And of course, the first thing so often all of these start with is with good, thorough literature review. So reviews can span a spectrum, all the way from a narrative review, that goes along the lines of use of phonocardiography in clinical medicine or comparison between different countries and the application of the recording of digital heart sounds and how much these devices are coming onto the market, all the way through to highly structured systematic reviews that can really assess things around such a project. So using the phonocardiogram study as an example, it would be something along the lines of prediction models that employ phonocardiography, or that could be prediction models that apply phonocardiography in a pediatric population. And you can adjust your scope with such topics to reflect the size of the review that you want to undertake. You can also bolster reviews like that with the use of approved guidance, so you can be assessing against some of the gold standard methodology that is out there for everyone to read in things like the Equator network is possibly the most important network of recognized reporting criteria for different things. So in relation to this project, those reporting criteria would be the tripod AI checklist, which is the transparency of reporting of prediction models that use AI, or perhaps the probast guidance, which goes hand in hand with that, which actually actively assesses prediction models for risk of bias. And you can use you can put those sort of papers into either subject specific places, like in this case, it would be pediatric cardiology journals, perhaps, or you can also attack them from a methodological point of view, where you're going into journals such as the Journal of Diagnostic and Prognostic Research, which is where I've done a similar review to this into prediction models around height and weight in both babies and children. And these sorts of papers are hard work in some cases, but really, really highly citable, because it's the sort of thing that everyone gets a feel of when they're reading the literature, that there's a lot of stuff out there that's not wholly reliable, but no one's really proved it and assimilated it properly. And actually, when you look at a lot of the fear of large language models and artificial intelligence from taking over people's jobs, you actually appreciate that they're actually nowhere there yet when it comes to doing things like accurately assessing the existing literature. If you try and ask ChatGPT to systematically review a topic, it won't do it very well unless it can plagiarize an existing systematic review that's been done by an academic. And so these things will be really highly citable for the first few years that they're out there if they're done properly. And of course, they can be done in any area that you're particularly interested in. Another aspect of this sort of thing is clinician questionnaires. So these are completely free to set up in the realms where now we can use platforms such as Google Forms or Microsoft Forms within NHS Mail that are quite professional and really easy to use, and you can use conditional branching and things to help people fill them out quickly. And some of these projects can be registered as a service evaluation project, so that you're not actually having to go through full ethical approval, depending on the sorts of questions that you're asking. But you can also go through those rigorous ethical processes as well, because they're not going to cost you any money. They're just going to cost you time, and you can submit university ethics or IRES NHS ethics for free. And so these questionnaires are really important, because once again, when we're working on the shop floor, you may well say things that you presume everyone knows, such as all SHOs hate doing baby checks and stuff like this, and that there's increasing things. But actually, when you actually look at the evidence behind those sorts of opinions, it's often not there. And sometimes you're wrong because you're biased by a certain centre, but sometimes you're right and your hypothesis is completely correct, but you just need to go about it in the right way to get the underlying data so that that can feed into a journal article and feed into funding materials. And so this is the sort of project where we could run a questionnaire, national questionnaire, to all of the NIPE midwives to ask them questions about what sort of aspects of the NIPE they're feeling more anxious about. If you think about the phonocardiogram project, there is now a change in service delivery in the sense that midwives are coming through midwifery school, all of them being qualified to do the newborn infant physical examination. Now, when you ask most midwives why they went into the profession, doing the newborn infant physical examination won't really be top of the list. And so there'll be some midwives that are really happy about that, but there's others that are likely to be quite anxious about it. And trying to assimilate those levels of anxiety is best done through a clinician questionnaire. And I've already talked to one of the lead senior lecturer midwives in East Anglia, actually, who's been involved in the creation of a NIPE app, and she'd be very keen to be involved in such a questionnaire if someone wanted to put that together and lead on that. And then that can easily become its own journal article in its own right. And I would suggest that that sort of project would be best put into a midwifery journal, but it can then also feed into larger funding proposals to establish the challenges we have around differing service provision by different allied health professionals and how they feel about it. What I'm getting at is, are all newly qualified midwives, is there any anxiety in their practice in being able to distinguish murmurs in newborn babies? We come from a world where you're listening to murmurs in medical school for years upon years to get some good clinical experience. And midwives don't have that opportunity during their training. But after their training is complete, after 3 years, they are effectively being expected to be able to pick up subtle newborn baby murmurs, and quantifying the issues around those changes in service delivery would be very useful. And in that sense, depending on how the questionnaire gets set up, it could be set into one of the informatics journals, like the Future Hospital Journal, or similar journals, which are thinking more from a systems perspective and personnel, depending on how you want to shape the project. But fundamentally, it will cost very little, if not nothing, to disseminate a national questionnaire and get some objective data about these challenges. But what I've put here about the behavioural design is the biggest challenge in these cases is getting a good response rate, and that's harder than you think. You think it's easy to put a questionnaire together, but it's challenging to make it the right length to get rich enough data without annoying all your respondents to ensure that they click submit at the end of the questionnaire. But that is definitely something I'd be happy to collaborate with if anyone fancied. There's also a lot of rich data sets out there that are analyzable if you do want to get into data analysis and data science. And it is incredibly important to get valuable, robust underlying data, but it's also mega important to be able to analyze it correctly. And if you've got no idea about analysis, you'll often find that the fundamental structure of the data that you've been collecting could have been done better if you then approach someone at a later stage to try and help you analyze it. And these publicly available data sets are really good to practice with, because you can struggle your way through online tutorials about data science, but it's really best learned with your own data, making your own mistakes, in order to truly understand the best way to approach complicated data sets. And in the terms of the phonocardiogram study, we have got access to things like the Circ or Digiscope data set. So if you wanted to get into data analysis, this has over 5,000 recordings of murmurs that have been expertly assessed by clinicians about their volume at different auscultatory points and whether there's a murmur, whether there isn't one. And the benefit of this is if you've got a small data set and you're playing around with it after you've collected it and after a small feasibility study, then you're highly likely to overfit your data or torture it until it tells you what you want it to tell you. But of course, if you're using publicly available data sets and you're using that project, if you like, to learn about the best way to analyze particular data, then it's completely outside of the data that you collect. So if you can do that early on with the sorts of data that you're hoping to get in a bigger research study later down the line, once you get a bit more experience, get a bit more funding, then you can torture it to your heart's content, and you're not going to do any damage or be accused of overfitting to the actual data that later on you most care about. And so I put speak to a statistician early there in quotes, because of course it is lovely to have the support of the statistician, and I'm supervised by a great statistician from Sheffield, so I'm lucky in that perspective. But it's not always possible. It's just expensive, and if you're not that experienced and you haven't got any funding, the idea that you can just sort of speak to a friendly statistician who's going to engage with incredibly complicated design questions is a little bit brave and a little bit naive, if truth be told. So of course it's always great to speak to a statistician about analysing data, but just sometimes if you're trying to do things on a shoestring, the support isn't there. So I really would encourage people to learn as much as they can, even if that's just by collaborating on projects where they're not necessarily leading on the analysis, but just paying attention to what's being done by other people, or what's been done before by doing things like the systematic reviews that we've talked about. But this is a bit of an example of the CIRCOR data set. I thought I'd just show you what is within there. And of course, phonocardiogram data is full of noise, literally noise in the background around murmurs. And so what you can do with that data set comes through in WAV files, which are just standard audio files. You can load them into a platform like R using other libraries that work within R. You can filter the signal. You can detrend the signal. So that would mean that if it's slightly louder at the beginning and quieter at the end, that it changes the signal to be more uniform throughout the whole recording. Then you can normalize it between 0 and 1, your amplitude being whatever you want it to be there in units. But the point being, 0 to 1 standardizes between patients. So you'll get some recordings that are louder, some recordings that are quieter, but then the normalization process will allow for better comparison. And then you can apply something called the Fourier transform to find out what sort of frequencies dominate the signal. And we'll see that in some of these examples. So in this, we have the original signal at the top, the denoised signal that's been run through the automated algorithm on the second line down, the normalized signal that's changed that same trace just to the they just rescaled it between 0 and 1, which you can see on the left axis without actually changing its constituents. And then the Fourier transform is telling us how many seconds or how many units of time we have for each of the frequencies of the signal. Okay, and fundamentally, you've got to appreciate, so in this example, we've got a murmur that was present and most audible in the tricuspid valve region. And the Fourier transform therefore shows that we have this collection of low frequencies, because an oversimplistic way of looking at it is murmurs are generally low frequency. So if you've got a low frequency, they will dominate the spectrum towards the lower end of the Fourier transform plot. And you can see that in comparison to another one, which is not quite as clear, but still clustered towards the left on the Fourier transform to show that it's a murmur. And you can do this for all 5,000 of the plots through the data set, and you can start to get some impression here. We've got a couple of ones that are murmur present on the left and a couple where the murmur was absent on the right. And we see those higher frequencies in the ones where the murmur is absent are more prevalent. So murmurs are generally lower frequency, and therefore the more shifted towards the lower end of the frequency spectrum that you are on the Fourier transform, the more likely you are to have a murmur. So it's going to be reasonable to predict. But the moral of this story is that all of the challenging work actually comes in improving these first few stages, improving the data pre-processing, and what machine learnists call the feature extraction that goes into your prediction models in the first place. And that's the sort of data set that you can use to test out some of the interesting things. But fundamentally, that sort of leads us quite well into explainable AI, because it's not necessarily difficult to fit some of these swanky machine learning models. Once you get into it, some of the code is only a matter of a few lines once your data's in the right shape. But the problem is explaining it to people, and that is explaining it to both patients, families, but also clinicians. And this is really where I think we sit, because when you have incredibly intelligent computer scientists working on these algorithms, they are fantastic at the computer science, but they don't have that inherent experience of explaining stuff to children, explaining stuff to families. And that is the biggest challenge here. This is a massive challenge that's being taken on by governments, being taken on by regulators, by the MHRA. They're doing a lot of work into the importance of explainable AI. And this is where collaborative working with people in those environments is really important. And whilst I've just said it's really difficult to get statistical support for free, it's actually quite possible to get support from people who've got interests in machine learning for free, because there's a lot of people out there who are desperate for really good applications of the skills that they've learned. Because what you'll often find is computer scientists go through 3 years at university doing a lot of um, really interestingly, methodologically interesting work, and understanding algorithms that we as clinicians would struggle to understand. But the actual examples that they're applying them to are often really, really boring and often useless. And they're frequently quite keen to apply their um, the skills that they've learned into things that are more valuable. And so I really would encourage you, if you've got your own idea about things that you want to use machine learning for, to try and seek out those fora where you can discuss with other people. Like in Sheffield, we've got the Centre for Machine Intelligence, and we've got a group called Insignio. The university put on sandpit events where they are linking up clinicians with people who've got expertise in things like machine learning, and that includes things like the South Yorkshire Digital Health Hub, who've got millions of pounds to invest in research, and they put on events that are specifically designed to try and introduce clinicians to people that have other expertise and other members of the research multidisciplinary team. And so I really would encourage you, if you've got your if you've got particular ideas, or you're just keen to get involved in someone else's work, but to add a clinical perspective to it, then finding out those events would be a great way to go. But equally, if you want to try and you're keen with the analysis side yourself, then there's a lot of work that can be done with explainable AI. You don't need your own ideas to make something more explainable. You can even take something from the literature, which is already published, and work on, right, how can we explain that to a clinician? Perhaps you're in a good position to be able to understand some of the nuances of data analysis that's been taken place in a journal article that you've read, but you've had to read it a few times yourself, and it's quite challenging to do. And just working on data visualization or other ways of explaining how the model works, often through examples or apps, can be a really good thing to do. And I'm happy to collaborate on work like that. In that sense, I've made a few apps in my time. One of these, you can access these apps by flashing the QR code on the screen. One of these is in relation to data visualization. I think I was going to show that actually. I've got that loaded up here. So this data visualization app I did with whilst supervising a computer science student. And in this app, you can open it on a phone, but you load in your own data as a comma separated value file, which is essentially just an Excel spreadsheet. And then you can assess different variables and plot them on the axis. So just have a general look at what data you've got. So say we wanted to look at age on the x-axis, and then on the y-axis we wanted to put weight of patients. And then we need to select a grouping variable such as ID in this case is a good one. So that's the ID of a patient. And we see how the weight in this data set is extending with age, and the lines there are a multi-level model that's fit through the data, which helpfully has the equation put down there. The little box plots here just immediately show you the distribution of the data, and then there's summary statistics that come up for the categorical data related to it, and you can even outline which of these outliers that we clearly see we had a bit of data entry error because the data is real, and we can adjust our outlier sensitivity there to give you a bit of a go. So this was sort of designed for a data access committee to be able to look at a data request for a registry and then use an active app like this to say, well, actually, how much data is there? How much missing data is there? How much data is available for those researchers to answer that question? The other app on that page just does some simple predictions about the short synaptin test that you can do by putting in someone's previous test results, and that was published. And so just a little idea for something that doesn't particularly interest me in relation to the topic, but it's just the sort of thing that I've occasionally been met with on the acute take in paediatrics when you've got a patient who is concerned, the general practitioner or someone has referred them in because of concerns about anorexia being significant and requiring admission. And our local guidance requires you to put their lying and standing heart rate, blood pressure, calculate their BMI, plot that on the BMI chart, relate it to their age, insert their have certain thresholds for electrolytes, the QTC on the ECG. It's quite manually laborious the way our centre is set up. And if someone had an interest in that particular disease, that's the perfect thing. That you could relatively easily tap into an app and make it a lot easier for clinicians to work out that calculation. And also less likely, I would argue, to make a mistake. But of course, to prove that, you would have to audit your service and things like that. And that's how that sort of project can actually spin off into multiple different publications, because you can produce a sort of clinical decision support tool, but then you can assess its use with a questionnaire, with service delivery changes, with audit to find out whether there were any mistakes before your decision tool was put in place and whether there were any mistakes afterwards. And then that's the holy grail of being able to say you've changed clinical practice, you've made an improvement, and you've got something tangible to show people, which they really like. Those things go down really quite well. And I'd be happy to collaborate on a project such as that. Patient and public involvement is really important these days, and there's loads going on in relation to the baby phono study, the echo, the phonocardiogram study, and these are getting more and more likely to be published in their own right. We can see this is a paper I came across recently where all of the authors here highlighted in yellow are actually patient and public involvement and engagement members. So really good to get people involved in the writing and the write-up of your work with the PPI. I think I actually discussed this at an NIHR event, and it's perhaps they've gone a bit overboard, not knowing precisely what everyone has contributed to that project. But I think there was certainly an NIHR view that having more than one or two PPIE board members on the publication is controversial, but of course it does depend on how involved they have been with the project. But that feeds really well into funding proposals. And it's the sort of thing that I'm doing a lot of PPIE at the moment in relation to phonocardiography, but I will not have the time to write it up. But if someone wanted to get involved in the PPIE side, help out with that, and then you could lead on writing it up and making the most of that sort of work. So I just wanted to mention some considerations that you want to bear in mind when we're thinking about research projects that are free to carry out, and that is open access charges, first and foremost. So it can, if you've got a really good piece of research, like you have spent a lot of time doing a significant systematic review, and you want to put it into a high impact factor journal, like the BMJ, then you will likely in this day and age be facing open access charges, which can run into the thousands of pounds. So it's good to check out the journals that you're targeting at the beginning. But what I would say is don't shy away from one, if you're trying to publish something on the cheap, don't shy away before you've tried to get funding. You should be surprised at what institutional support there is, especially for early career researchers where people are trying to encourage you. And there is an understanding that you're in more of a vulnerable position with regards to lack of funding. So by that sense, you can apply to the university, you can apply to hospital trusts, and often there are little budgets for these things. We say little in the sense of the NHS, where there might be tens of thousands of pounds, but washing around. But there's budgets that often come to the end of the tax year, and someone's got to use some open access funding before the end of the tax year. So if you can time things well for that, and sometimes they could charge that out before you've got your paper approved or something. Other times you need to have it approved first. Look into it, but do fish around and try and find out whether there is support from your institution for open access, because open access is a good thing, and everyone is trying to jump on board supporting people to comply with it. Collaboration and support. So bear in mind that if you are doing this stuff on the cheap and you're using data sets to develop skills, then that is really good, but you've just got to be careful with how much support you can expect from people. It might be tempting to go to the highest professor in the university, who is a world expert in the particular disease that you want to do, and that certainly is a way to get on in research. But the way to get on in research in that sense is do as you're told and do what they want you to. If you think that they're going to have a lot of time to literally coach you through how to make your own app or something just because they've done it themselves in the past, you've got to be careful. So appreciate that depending on how many skills you've got going into a project, just appreciate that you might not be getting that sort of day-to-day or week-to-week support that you might want if your supervisors are very, very busy. So that's where collaboration amongst the region through the Bridge Research Network can really help. And think ahead. Okay, there's loads of people try to get a publication just before they're putting in a grid interview, just before they're trying to go out a program or something like that, and it's just unlikely you're going to turn it round in time. You can always talk about projects that you've got ongoing and things, but it really is quite rare to get from an idea to a publication in less than a year. And realistically, you're doing really, really well if you're turning something around in less than a year, unless you're very, very good at doing a review, and you're very quickly assimilating knowledge that's already out there and writing it well, and then you could maybe get a review done quickest. But there's always going to be delays for peer review, and it's a slow process research sometimes that's completely different pace to clinical work. So just bear that in mind and think about your the next step beyond what you're trying to go through. So I think there's loads of ways to do research for free. Systematic reviews, questionnaires, data analysis of publicly available data sets, PPIE, visualization projects and AI explainability, and getting into creating your own apps or getting someone else to create an app for you and then applying it in clinical practice. And that's where we can collaborate and publish across the region. So if you did want to collaborate with me, I'm more than happy to for you to get in touch via my email address, but of course you can get in touch via the Bridge website on the QR code there, or the Bridge website email address, where someone will get back to you and we can foster those collaborations. Okay, I'm going to leave it there. Thanks very much for everyone's attention.
Thank you very much, Neil. That was amazing. Does anyone have any questions? I can't see anything in the chat. If anyone wanted to ask anything. No? Okay. Well, that was really interesting, and I loved the apps as well that you have helped develop. That was great. So a little bit about, shall I?
Stop sharing.
Yeah, I'll just share this just for the last few slides. Oh, it's not sharing. I don't think Diane is here. Just 1 second. Sorry, because I also have a baby on me. I'm trying to multitask. Right. So what we'll do is I have the feedback link here in the chat if you'd like to go on to this to give us some feedback. It's always very helpful. And also just to talk about our upcoming events. So on the 24th of April, sorry that I don't have the slide up, but on the 24th of April, there will be a link going out. We will have the opportunity to hear from one of our colleagues, Dr. Charlotte Fuller, who is a pediatric registrar. It's on lessons from children research in Malawi. So she's going to be talking about her work that she's done in Malawi, which will be very interesting. So look out for that, please. And if there isn't anything else, oh yes, and please do visit our website. It's the Bridging the Gap website, and there you can learn more about our group. So, is there anything else you wanted to say, Neil?
Oh, that's great.
Thank you very much for today. That was very great. That was amazing. So, all right. Well, we'll see you all next time. Thank you very much. Have a good afternoon. Bye.